Today we are going to start a lecture series on the subject of introductory mechanics, and in this first lecture we will talk about the definitions of mechanics and its sub branches, kinematics and dynamics. As you know that motion is an important topic in physics, and mechanics is that branch of physics which deals with the motion of the objects, and it can be further divided into three sub branches. The first of them is statics. In statics we deal with the bodies which are at rest, or we can say that the forces acting on them are in equilibrium. The good example of it is electrostatics, where the interaction between two stationary charged particles is dealt. So it is an important branch of mechanics, but there are other branches. For example, the kinematics. In kinematics, we deal with the motion of the objects, but without mentioning the cause of the motion, that is forces. It is an important aspect in motion, where we can just understand and analyze the motion without even considering the cause of the motion, that is forces. But once we are interested in knowing the cause of the motion, that is force, then the sub branch of mechanics is called dynamics. So in dynamics we deal with the motion of the objects, but we also consider the forces. So let's in detail give you the definitions and example of kinematics. So as we already said, that kinematics is that branch of mechanics in which we deal with the motion without mentioning the forces. Let's understand this with the help of an example. Consider that there is an object resting on a certain platform, and that object falls through height h to the surface of the earth, and the initial velocity of that object is let's say called v, and the final velocity is u, and it falls with the acceleration g, that is force due to gravity produces this acceleration. Now if we want to understand the motion of this object through the force of gravity, then we can relate these all parameters, that is initial velocity and the final velocity and the acceleration, through an equation. This equation, for example, there are other equations as well, but this equation is totally a kinematical equation, because there are no forces involved in this analysis. So you have seen that the parameters of motion can be related and can be calculated using these equations of motion, and there are other equations of motion, but I have just give you an example that where no forces are needed in order to understand the motion of the objects, and this analysis is called kinematics. And such analysis is applied in many areas like algebraic geometry, engineering, biomechanics and astrophysics. But once we decide to also consider forces, then the other branch of mechanics in which we consider the forces is called dynamics. So here the forces are present. Forces are always present, but we include them in our analysis, forces and masses both. Then we call it dynamics. So let's go back to our original example, where we have seen an object falling from a platform to the earth, and in this case, if we consider the force of gravity as well, then the equation of motion is this Newton's second law, and here you can see that along with these kinematical equations, we have F is equal to mg, where g is an acceleration and m is mass. So m and f both are present here. There are other forces involved as well. For example, the frictional force due to air resistance, or other kind of frictional forces may be involved here. So if we consider them as well, so we can simply add this frictional force to the original force. So you have seen that now the forces are involved as well in the analysis, And such an analysis also has a lot of applications. For example, in mathematics, engineering, biomechanics, and physics, the dynamics is included. So overall, mechanics is study of the motion, and it's an important aspect of the mechanics where we can just neglect the forces and analyze the situation without them, and this is called kinematics. And if we are interested in the forces as well, then it is called dynamics. Thank you.